This is part 13 of the series Right Triangles and Trigonometry. In this part we're going to work some examples using the law of sines and the law of cosines. In this first example we're given a triangle ABC and we're asked to solve the triangle. What that means is to find all the missing sides and all the missing angles. In this case we're looking for side B, side A, and angle A. So let's begin. We can first start, the easiest place to begin is to find angle A. We can use the triangle sum theorem to just subtract 47/72 from 180, so this angle then becomes 61. So that one's an easy one. So the measure of angle A equals 180 minus 72 minus 47, which equals 61. So this is 61 degrees. Alright, now that we have all of our angles, we should be able to set up some relationships to solve our sides. Now the first thing I notice is I have an angle opposite a side. That's a key that I might be able to use the law of sines. And since I'm looking for another side, let's go ahead and use these two, this angle, this side, and this angle and this side. So the first thing I'm going to do, I'm looking for angle B, so I'm going to set that up first. So B is 2 sine 47, using the law of sines, equals 19 equals sine 72. So this is to the sine of this as this is to the sine of this. And that's our relationship. Now we just solve this proportion as usual. B equals 19 sine 47 over sine 72. So let's go ahead and bring up our calculator and put that through. We have, I'll put a parenthesis here, 19 sine 47. I'm going to close the parentheses for that sine, close the parentheses for the numerator, divided by sine 72. And we get 14.61. Now, we have B, which is approximately 14.61. Now we're going to have to do this angle. So let's set up another proportion looking for this side. So A is 2 sine of 61, as we can go ahead and use this. I'd rather use this than a calculated value so that I get a more accurate result. And that doesn't look much like a 6 either. Okay, so that's 19 over sine 72. And let's solve this for A. So A equals 19 sine 61 over sine 72. And we'll put this in our calculator. Parenthesis 19 sine 61. Make sure we close our parentheses properly. Divided by sine 72. Enter. 17.47. So this side is approximately 17.47. So with the law of sines in an acute triangle, this is fairly straightforward. We didn't really have to do a lot of energy. Basic problem. Now let's move on to another problem. In this example, we have a bit of a different situation. We have an obtuse triangle here, and we have two sides and a non-included angle. Now, in this situation, we have to exercise caution because we're okay if they give us an obtuse angle, but we're not okay if we're looking for an obtuse angle using the law of sines, and I'll explain that in a second. But let's go ahead and set up a relationship here. the first thing we're looking for is angle C. So let's go ahead and find angle C and establish a relationship with these other pieces. So here we can say, since C is our missing angle, let's say the sine of C over 15, which is side C, is equal to the sine of 117 over side A, which is 23. Solving for sine C, we have sine C equals 15 times the sine of 117 all over 23. And now we have to solve for C, so we have to unlock the angle out of the function, so we're going to use the arcsine function. So arcsine of this side, and then we have to take the arcsine of this side. Therefore, C equals arcsine of 15 sine 117 all over 23. Now here's where the peculiar part comes in. Remember, in a previous example, we were able to take the sine of an obtuse angle because the sine of an acute angle and the sine of an obtuse partner angle had the same sine ratio. So this angle and this angle have the same sine ratio, assuming that this angle and this angle are congruent. So that makes this one okay. The problem is that the domain of arcsine is negative 90 degrees to positive 90 degrees. So we would only be able to plug in an angle that is between 0 and 90 into the arcsine, or a ratio that gives us an angle between 0 and 90. So in this case we're okay because this is going to be within our domain. So you have to be very careful when you're looking for an angle that's outside 90 degrees, because arcsine will not generate an angle greater than 90 or negative 90. So let's go ahead and put this in our calculator and see what we come up with. Arcsine of 15 sine 117, close our parentheses, divided by 23 gives us 35.53 approximately. Degrees. So we have an angle of 35.53 degrees. And now we're going to have to use this angle and this angle to subtract them from 180 to get our remaining angle, angle B. So bringing back our calculator, we have the value there, so I'm just going to store it really quick into X. And then we're going to say 180 minus 117 minus this angle which we just stored in X. And so angle B then becomes 27.47. So this angle is 27.47. All right, I hope this explanation of the arcsine wasn't too confusing, but just be cautious. We're going to see this again when we work with the law of cosines example. Speaking of which, let's go ahead and move on to another example. In this example, we're given an angle and two sides that include that angle. We have no side opposite an angle, which means that we're not going to be able to use the law of sines because we have no way to establish a relationship yet between an angle and a side. If we had one pair, we'd be okay. But we don't, so we're going to have to resort to the law of cosines now. And the first thing we're going to go ahead and solve for is this side, because this side is opposite this angle. So let's start the technique. Law of sines, or law of cosines, says that a squared equals b squared plus c squared minus 2bc cosine of the angle opposite that side, cos A. So that means that a squared, this side, equals b squared, which is that side, plus c squared, which is this side, minus 2 times b times c cosine A, 42. Now this is a fairly straightforward calculation that we can do, but before we do that, we're just going to take the square root of both sides. So A equals the square root of this whole thing. 13 squared plus 16 squared minus 2 times 13 times 16 cosine 42. And we put that in our calculator. Let's move this over here. And we have square root of 13 squared plus 16 squared minus 2 times 13 times 16 cosine 42, and our result is 10.76. 10.76. All right, now that we have this side, we should be able to set up a relationship with this angle and this side, this angle and this side. Now it's always questionable to use a calculated value to find an approximation, but in this case we don't really have a lot of choice. So before I go any further, I'm going to make sure that I store this value. So this is stored in alpha A. So now the value is stored, and I'm going to put a notation here that I've stored the value in A. Alright, now we're going to set up an example of law of sines. So I'm looking for this angle, so we say sine B over B equals sine A, which is 42, over A, which is this guy. And I'm just going to put the symbol that I used here so I can use my memory location for this value. Solve for this value. Sine B equals 13 sine 42 over A. Now we take the arcsine of both sides, so B equals arcsine of 13 sine 42 over A. Now the discussion I had last time about arcsines is very pertinent here. The reason that I picked this angle was because clearly this is the smallest angle. This is the next smallest angle because it's opposite the next smallest side. So this is going to be my biggest angle. And I want to do my acute angles first, because if I don't, then I'm going to have a problem with arcsine, because arcsine only generates angles between -90 and 90. So that was the issue. Let's execute this calculation. Second sine, that's arcsine of 13 sine 42, close my parentheses, divided by alpha A, because I stored my value in alpha A. And so my angle is 53.91, which is a nice acute angle, so we're in good shape. 53.91. Now it's an easy process to find our missing angle, so let's type it in, and we get 84.1 degrees. Let's work another example in the next part.